que tienes que poner es la de con quién nos conectamos.
The presentation that you need to put is who do we connect with.
Bueno, vamos a
Hacer todo el inglés.
entonces.
So we're going to resume the tutorial. This part complements what Hernan and Guillermo said earlier in the first part of the tutorial. Now we are going to focus on learning important aspects with regard to the information that we need to know when we define and we decide who we connect with. So we are going to talk about the content networks, the CDNs, the providers of the content distributed platforms that develop with having global servers for distribution to send the content to global users with the information through cache servers so that can be consulted more efficiently. Also improving not just the performance of all these services, the content services that are provided by the internet providers to all their customers, but also improving the issue of costs that you have when having access to the content and the time to response to the different contents. So everything we see about the contents of the internet, the traffic that the CDNs generate, all the content that they have access to through the various content providers, for instance, of streaming. It's about the highest percentages that we have today. There, I'm showing you some examples of the best known CDNs. Some of them are only content providers, and the others that, in addition to being content providers, are also telcos. You have. So now let me show you the statistics available for El Salvador with respect the population, the people living in El Salvador, the number of individuals that use the internet through mobile connections and through the website with end machines. So for the 6.35 million people in El Salvador, the 100% is identified in the number of mobile connections. 4.88 million people use the internet, of that 6.35 million. And then we have a relation. Well, then we have the users that use the different social media. As to growth, if we consider the number of the people in El Salvador, over 160% are identified with the connections through mobile connections, 10.2 million connections. And if we compare that versus the statistics for 2024, there's a growth that is not too high of 1%. There's a 1% growth. And with regard the 4.88 million connections with the internet, this accounts for 76.9%. And here I wanted to show you a significant piece of information about the growth of the internet users one year after year since 2015. That is the last 10 years to 2025. We've always had positive increase in the number of users year after year, but we want to highlight that last year the that increase was 7.7%, quite a significant increase. And here we are comparing the speed, the internet connection speeds, both from mobile devices and machines with a download speed of 33.22 download and 15.43 upload. And in the PCs, it's 71.15% download speed and 19.29 upload speed. So this is data from February 2025 and we compare this against the study of February 2024. The number of the percentage of a connection, the number of users in the internet and how they access the internet, how they access the traffic that gets generated annually from what devices? Mobile devices, tablets, laptops and desktop computers, and other devices, including gaming platforms.
In order to have data and for us to be able to have data with whom we can interconnect, one of the most used database is PeeringDB, which is a platform that's used worldwide. It's public and it enables the interconnection. Is one of the first points in research to have more information of autonomous systems that we want to have interconnection with. It's a public database, it's open, so it promotes transparency, and the users of PeeringDB, I'm showing them here, are the ISPs, CDN, the CDN that I was talking earlier, and all those providers in the cloud or hosting. In this database, we will find technical information and also contact information of the different networks. And it is updated. I want to show some requirements, some information that we need to think of when about this platform. It's open. The goal is for the public to have information in relation to interconnections. You shouldn't be able to extract information from this platform for commercial goals. the accounts must be associated with an organization, a legal established organization, and those accounts must be validated by the team of Peering DB so that we verify that it's not an individual account and it's from a corporation. We in our company we can have different users. Some may use the platform just for reading, and some others may be able to add information, update data, etc. about the data from the organization. And we can set the roles there. There are several APIs also, so that the updating can be done automatically, and so we are more efficient. It's one of the most used tools for peering data. When we are establishing a peering relationship with a provider, then it's very common that we are requested to be here in this platform, in this Peering DB. We need to focus on updating information, and the more information that we add in this database, the more we will help others, especially those who want to connect with us. We can also add information of the presence points that we have, the types of interconnections, in order to have a physical link with other teams, such as the fibers that we will need to establish physical links in those presence points. So this needs to be updated, and the information must be linked to the peering policy in our organization. Here you can see an example. This is a query from Cable and Wireless Panama. So when we register in Peering DB with a with a company account, then this account will be linked to a network, and that will be our autonomous system. There's a verification going on after that the autonomous system is linked to our organization, and then we can add data in that network. Here you can see some information. We have segment information, autonomous numbers, and the last updates.
So here I'm showing specific data of the points where the network is present. Here I give you a list of the first steps that you have to follow if you haven't registered in Peering DB, or if you are trying to have new connections with some peering providers. And in this platform, you can also see the peering policy established, those requirements requested by some CDN or some additional provider, about the contracts or the agreements that we want to establish with them for peering, from the physical connections to the amount of traffic that we need to generate for a CDN or a content provider to give us their okay to establish that connection with them. That is something that happens very frequently, and many content providers request a minimum traffic so as to define whether it's really necessary to establish that peering connection with them. To enter the website of peeringdb.com, you register with a user's account. It needs to be a corporate account, and it will have to be validated by the PeeringDB team. And then you go to the next step, that is the corporate registry. You have to add it to the network registry, that is the autonomous systems that we want to register there. The more information you get, you enter, and the clearer and the more updated, it's going to make it easier for the networks that wanted to get in touch with us. So, and finally, before we go to other issues with respect to this part of interconnection, Hernan already mentioned and emphasized the importance of the traffic exchange points, and Guillermo mentioned the issue of the traffic exchange issues. And based on that, I want to talk about the mutually agreed norms, manners, for the security of routing, focused on, to meet the objectives of raising awareness about all the players in the system of the internet, and not just the operators, not just the network operators, but all these new entities that appear in this ecosystem, such as the IXPs, the contents providers, the cloud service providers, the vendors, and being able how to deliver a framework, identifying specific things to strengthen the security system in the routing of the internet. Among the actions, it will also focus in this framework to be able to generate that culture to quickly respond when there are problems or incidents that may arise in this internet ecosystem. And based on that, these are the actions indicated. Specifically, they focus in finding solution to these three types of problems related to the incorrect routing, the traffic of spoofed IPs, and those concerning the coordination and collaboration between the different network operators and these new groups that appear in manners. And here I want to show you the specific program for IXPs. The initial program of manners was in network operators. We specified this on Monday. Here I want to show you the actions that these IXPs need to meet, considering the significant role they play in this ecosystem of the internet, since they are one of the strategic partners for promoting the strategy of manners, because they encompass many of these network operators that in the end up implementing specific actions from the other program. So in the IXP's programs, there are 5 actions that need to be met for the IXPs to have a manners certification. This certification, as I said, is a global certification. It has no cost whatsoever, and the only thing that it requires is to complete the action so that you can certify that you meet the standards. We have those 5 actions. The first of which is to facilitate the prevention of the dissemination of information of incorrect routing in specific activities related. That includes filtering the route ads in the route server using the RIRs or the RPKI. The non-valid announcements are filtered following the public policy of the policy published in IXPs. So in Action 2, they promote manners between the members of IXPs. The IXPs promotes or improves assistance so that the members implement the actions of manners. So based on the monitoring of the IXP, well, the organization has the information of the traffic of all the members that are connected. They have the information in that route server. I don't remember whether you remember. I don't know whether you remember the topology that Guillermo says. Now there are no BGP sessions between each of the members, but there's a relation, and we get the routing table of the different members, and there we will implement the validation. And in those routes that we have centralized in that route server, we'll be able to see the validation states, and based on that, we'll be able to establish the filtering policy. That's the ideal thing. If we don't establish that, we see many invalid routes in our infrastructure. We are doing validation, and we see 100% we are receiving invalid routes, and we don't filter them, then we are not doing that action, and we can't get the certification by manners. Another activity that is included in this first action is the responsibility that the IXP has to report to its members that the invalid routes that can be seen here are the segments of the members. So they have the responsibility of letting the members know that they have invalid routes, and that they should adjust things so they will no longer be invalid. The second action is absolutely linked to what we mentioned on Monday in the tutorial, and that is to implement this initiative among the members of the IXPs that know that there is a program for networks operators so that they can start implementing actions in their infrastructure. And that is done showing what are the talks, what has been done with the members so that they can have information, get prepared, and so that they can implement this initiative. So we have, well, Action 3 is protecting the peering platform. That is all the filtering that needs to take place. The government policy in the country, and also filtration agreed by the members, establishing or indicating how that filtering is taking place, and that policy that is published in a database such as PeeringDB, for instance. So and Action 4 is facilitating communication and coordination of the global operations between the network operators, that is establishing contacts, updated contacts that may give us the possibility for responding in case of an incident. Usually these contacts are of the network operators. The mailing list should be updated so that all the members can get actively communicated, establishing communication if there is some type of incident, problems with operations, security, abuse, so that things can be done quickly to mitigate it. Action 5, the last one, is providing monitoring tools and clearing tools so that the members connected may see information of their network and their peer networks with whom they are establishing their connections. So normally from each IXP they have some monitoring scheme, such as a looking glass to ask queries, so that not only the people that are operating at the IXP may have the data, but any member should be able to enter these platforms. So you may notice that many of these actions have a lot to do and go hand in hand with the actions that the IXPs or that the ISPs need to provide. The network operators of the Manners program. And as I was telling you, I leave you that information so that not just as IXPs you may promote the use of these initiatives, but that you may also know these actions that actually the impact may be quite large in terms of what you can achieve with this type of implementation. There are many IXPs that are working to get certified, and the action that is more difficult out of experience is action 1, filtering invalid routes, because it all depends on the percentage of traffic that is invalidated there and the quick action by the members to update the ROAS, and so that these routes won't be considered invalid anymore. So this is what I had to present. I don't know whether you have any questions or comments. All right, so I'm going to give the floor to Nico and Ariel. Well, we're going to do this 2 or 3 together. Nico will give the presentation on best BGP practices, and Ariel and we're going to boycott his presentation. Now you go there and we'll boycott it from here. All right. Good afternoon, everybody. This is difficult, having to give a presentation after lunch, because from up here it is quite terrible to see people sleeping. Today, let me start with a question. Raise your hands if you work in operations, in network operations. Who works in network operations? Raise your hands. There you are. Put it down. Of those of you who raise your hands, or maybe some that didn't raise their hands, who operates the BGP protocol? Good. This is going to be fun. It's going to be fun. So let's give the presentation. What you have there is true. It's not joke. This presentation, the slides, we use them only as guidance. The idea is to do it dynamic and to participate to the extent possible. Comments and questions, not just questions, comments, contributions, feedback, describe the way you do things or that you've heard of, and so that we may all learn from each other. And of course, questions, but don't throw any sharp objects against us. So this presentation, in the past, in LACNIC events starting in 2010, the first time that we gave this presentation was in 2010, and then we did it for some time in this space. That was the peering tutorial. And then we changed it for other spaces, and now we decided with the people of the working groups and the PC of LACNOG, we decided to bring back this peering tutorial part and to include the different topics at the different events. Let's start. This is a set of good practices and techniques applied to BGP. So, this is a sort of reference when you see these small icons. There's no absolute truth. There's no one single way of doing things in BGP, two, three, several ways. And none of them, a priori, none of them is the very best. In some cases, there are recommendations with some basic aspects and some things that are recommendations that are not debated.
But then for the rest of the thing, that depends on the type of networks that you use. So these are just recommendations. So just and it doesn't mean that if you're not doing it this way, it's wrong, or if you're doing it this way, is right. No, we need to consider each case. I didn't understand anything you said. Those emojis, what's their date? They are from 2010. Yeah, we didn't have any modern emojis at the time, but they are still from 2010. So let's start. Some very basic things about BGP configuration that no one does. When you will configure BGP against peers, there's BGP multi-hop. You can configure the number of hops. Who uses multi-hop here? Who has high levels of BGP in their BGP? Raise your hands, those who have BGP sessions of more than one leap hop. Very good. When I asked who was using multi-hop, I had 2 hands raised, and then for who's using hops, then I had like 5 hands raised. But if I'm connected to the peer and I go directly to the hop, that's only 1 hop. You have 1 BGP hop, and you're using the configuration, the default configuration. So by default, it's just 1 hop. If you're using multi-hop, then how many hops? 256. So if you're configuring multi-hop, then you can have 2, 3, 4, 5 hops. If you don't set a limit when you activate multi-hop, then by default it would go to 256 hops, and that's useless. So the ideal thing is to limit your hops, and the advantage is that it won't be possible to have a BGP setup of more than I have configured. So not 256. Well, yeah, 255. Yeah, he's right. Thomas is right. Using MD5 to authenticate peer. Raise your hands. Who is using MD5? Yeah, there are many. I thought that everyone was going to raise their hand because that's a classical thing. But that's highly recommended. No, you didn't like it? No, you can comment. Do you use it? Okay. It's a good thing to use MD5 so that messages are authenticated. So I know that the relationship is with the peer and with no one else. In general, you use a shared key, pass key, and we agree on that. And the keys must be the same in both sides. The passwords. Yeah, MD5 is not that safe. So it can easily be to using access lists to allow updates.
Raise your hands if you do this. Very few hands. This is also a very good practice, just enabling access routes to allow for BGP updates only of the peers. If you do that, remember that you have to enable the port that is used for BGP, because BGP works on TCT. Then next, whenever possible, avoid redistributions, reallocations from IGP. This is a general good practice to generate the BGP publications and to disseminate routes that I receive through BGP in the network whenever possible to avoid reallocations. Who uses reallocations? Well, after what I just said, nobody will use them. Who uses reallocations from BGP to IGP or the other way around? I see 2, 3, 4 hands. Good. Why is it in general, and this is not absolute truth, why is it usually advisable to reallocate? Well, allocation should only be used if necessarily you need it and you know perfectly well that you have a very strict control of what you're doing. If you reallocate everything, it may be chaos, because anything in the internal protocol will be distributed to the BGP and the other way around. And one of the problems of that, it has 1,000 problems, but one of the problems is that the speed of convergence of the internal protocol that is not BGP, the speed of convergence of a protocol as IPF is much faster than that of BGP. So when you redistribute, but why is it that that speed is much faster than the external protocol? Because somebody thought of putting arbitrarily a small or a big number? No, because the internal protocols, you assume that the prefixes and the conditions of the network change much faster than the external routing. So the protocol needs to converge and react much faster. But when I have a reallocation, whenever something changes in the internal protocol, I'm obliging BGP to converge. If it goes very fast, if I don't do things well, they have to be converging all the time. If I reallocate because I need to and I do things right, that won't happen. That is why you need to be very careful when you reallocate. Reallocating everything, in my view, is not a good practice. Redistribute any is not a good practice. Redistributing is mixing two protocols that are probably very different. So each protocol was designed for a specific purpose. And when you are doing a command, usually you call it redistribute. When you use a redistribute, you are picking a protocol with a certain shape, a certain number of metrics, and a certain number of things that are being measured, and you're obliging it to adapt to a completely different mold, the internal, IPF, or static, or whatever, to BGP or the other way around. What you're doing is basically requesting the machine that by force it should change absolutely all the metrics, adapting them to the protocol of destination. So it's not just that a protocol is faster than another and may be too much for BGP that was initially designed to be slower, to be more stable. I don't know whether it's like that with the new networks, but that's what we initially thought. But in addition to that, you can lose a lot of information of the original protocol when if you force the injection of the information in the BGP protocol or the other way around. So many of the things that we are going to see, for instance, if you distribute BGP within an IGP, not recommended at all. You would be losing all the information of BGP because the IGP won't support it, and the other way around. It may happen, something similar may happen. And of course, you may get congestion in the machines. And if I don't have filters, I'm publishing all the blocks in the internal protocol, a disaster. So, possibilities of a centralized management of publications. Well, usually all that operate a BGP protocol, there are several things that need to be met to generate a BGP publication to the peer. Basically, you need to have the route in the routing table of the device, and you need to put the appropriate network for that prefix in the BGP session. So the first question is, raise your hands if you generate the BGP configurations putting the network and, for instance, a non-zero route in the border routers. A null zero. And now raise your hands if you do not generate the prefixes in the border edge without a null zero route. Maybe you do it some other way. So almost everybody does it with a null zero. And a third question, raise your hands if you have any automated systems to generate the publications. Zero, nobody. Later on, we are going to talk about the centralized management of publications, and I'm going to give some ideas for debate so that you may evaluate. This has several items that are important. The best is if I manage the BGP publications in the border routers, putting null zero routes and putting and taking networks, that is quite good if either you have an army of people handling the border routers, or I have just a very few border routers, because if that is not the case, every time that if there's something catastrophic and I have to start moving blocks to balance the traffic, you may go crazy. And you have to remember who was where, etc. It's a chaos. It works very well when I have just a few. By few, I mean two. More than that, it's chaos. And each with very few links, outbound links. Internal use of communities. Raise your hands if you use BGP communities to manipulate the traffic or to manipulate properties of the prefixes. Okay, good. Ariel, this is yours, so make a comment. Communities. Communities, well, you speak of a descriptor, a number that you put to a prefix, a route, and basically a BGP community is a set of routes that share certain characteristics in common. It is clear that our transit providers, or usually the external peers, should publish a community table. So maybe we should call everyone to publish their community tables, but this is for external. Why should I work with the communities externally? Usually to show the origin of traffic, especially in large networks. We apply communities to say, well, I'm learning these routes from a certain city or a certain sector of the network. That could be a classic example. Another example could be to avoid using communities between peers and BGP. It would be a good use, for instance, to mark all the routes that I receive from a transit and to add a community to say, I received this from a transit, to prevent another external peer to republish it externally. That is, not to give transit to external providers. And then there's a usage that is maybe smarter. There are some CDNs that give us the possibility, for instance, of that we can inform them, this is external, but we have to market from within to tell them what kind of client we have or what kind of client is grabbing the route that we are using. Why should we do this? For instance, if I have mobile clients or if I have clients that I know that they have a low bandwidth, through communities I can tell the service of a certain CDN that those clients have a certain a limited capacity, a different capacity of way of receiving the content. So the CDN receiving those communities that were previously prearranged may arrange, they may do buffering differently, or they may adopt a different quality of service policy toward the prefixes that are sticking to those communities. And the other classical one is that I may do policies for routing traffic based on distinguishing some clients that are more important than others based on the prefixes that I receive. That is a certain number of prefixes that have a common characteristic. There you have to be creative. And essentially, especially when we speak of the centralized management of publications, usually you generate a device in the network. Then we are going to see this within the network generating the publications, and you take different communities so that the routers in the border may know where they have to send them to. And the idea is that basically the control of traffic and the payload balance and everything you do with the prefix may be done based on predefined communities in the network. Excellent. I have a question of your BGP test. Are the communities attributes that are transferred from IGP to BGPs or not? Well, here it's full of people that know more than we do. Do you transfer the community or not? Creak, creak. What happened? Are you asleep? Are we all asleep? Ariel, do you transfer this to a community or not? Well, it depends on whether it's raining or not. If I don't filter it, yes, sure. Transitive, optional. Transitive, optional. Right. So that means that you need to be careful when you use communities internally, when you generate the publications, if those publications are marked with a community and I don't eliminate the community, for instance, or if I use communities internally that my provider may repeat internally and use it for another thing, and I am transferring it. I may be adopting actions with my prefixes that I don't want just because I forgot to eliminate them and they were transferred to the provider. And there you have the mark. Depending on the software, there are some that by default they have them off, and then you have to turn them on. There are many flavors. That's right. You must take it into account. So let's talk of how we are generating the publications. This is the scheme of a network. It was in the I wanted to save time, so I drew it and just by hand. The pair of scissors is okay. It's the only good thing. Yes, because I pasted it. But forget the pair of scissors. This is a core of the network with 4 routers. BR1 is a border router. And in this scenario, I ask, who generates the publications? I ask a question, and you raise your hands, announcing our null-zero routes and networks in the configuration of the BGP session. Raise your hands again if you generate the sessions like that. Alvaro Retana has an ulcer now while you present this diagram. Why? Why should he? Well, what are the problems? This may be the most popular mechanism for generate publications, but what's the problem here? For some reason, It didn't appear there, but so this is one of the most commonly used, but it has some problems and quite serious. For instance, what happens, and here I have the pair of scissors, if I come and I cut this link between the border router and the core of the network. The border router has configured null zero routes for some of my prefix and has configured an access. I interrupt the connection between the backbone and the border router, and the border router continues to publish things, and the traffic continues to come to this border router, and it's a black hole, a huge black hole where the traffic gets lost, and it's never going to get to my network because this link is no longer there. But the router continues to publish because they have everything. They have the null zero route and they have the network, and this has another problem. Raise your hand if you have management outside the band for your border router. Okay. Less than half of the ones that raised their hand saying they administered BGP. Well, in that case, I'm going to connect to the border router. I'm going to remove the networks, for instance, and there I will no longer publish. Or if this got cut, I enter to the border router and I leave the BGP to solve this problem. Now, if I don't have out-of-band management, I can't connect to the border router. And if I don't have communication with the border router, and the border router continues to send the prefixes, if the border router is in the data room, I can open the door and I just pull the fiber to put an end to that BGP session. But if the router border is in a data center 45 minutes with no traffic of the operation centers, you want to kill yourself. So a way you can do that with the same effort, but a bit more, not as risky as those cases, it's here, this. What if we leave the networks, because those have to be in the BGP session of the border router, but the null zero routes, instead of putting it in the BR, we put it in the core. And if I interrupt this link, the network continues to be there, but what disappears in the route? If the null zero route is in the core, then automatically you no longer publish those prefixes and I don't do anything. It's automatic. What is the only difference in configuration? It's where I put the null zero routes, right? An additional improvement would be this here, that is what Ariel mentioned earlier. What happens if we maintain the networks in the border router? You can't remove them from there, but the network, we add the BGP configuration of the border router, the use of internal communities, just as suggested by Ariel a while ago. That is, I add a configuration of BGP to the border router so that the prefixes coming with a certain community, I publish them with this link. And the prefixes that are coming with another community, I publish them with another link, and so on. And that is a configuration that is almost never changed because I have that template. I stick it in the border routers and I configure it only once. And then I connect. Well, one is not a good idea. You'll see why. I connect at least 2 machines to the core of the network. Those 2 machines can be any type of device that supports raising a BGP session against a router. There's no need for it to be a router. It could be a software emulating this. It can be a soft router, an FRR, with a machine that's relatively small that only needs to support the BGP, because these routers that I'm connecting to the network are never going to receive traffic. Never. And what will these routers do? These are the routers where I'm going to generate the BGP publications. In these routers, I'm going to put the null zero routes, and I'm going to mark the blocks. In addition to putting them null zero, I mark them with certain communities, as Ariel said. If I mark the blocks with a certain community, when that BGP, well, of course, you need to have BGP in the network. If not, it doesn't work. When the BGP information reaches the border router, then the border router will do something depending on the community that each of the prefixes come with. So I have a machine here where I generate all the publications of the network. When another machine there, it's just synchronized, and every half an hour they copy the configuration. So if that one dies, this one keeps on working, and if the two of them die, then I'm done. Well, there's, for instance, ExaBGP. Do you know it? It's software. It's Python libraries, code pieces that you can use to read centralized databases, and from there to generate the BGP announcements in that small router, or those small routers that you can install for the origin of the announcements. And when the information of reachability reaches the border, depending on the community that is taking it, it will go to a provider, to the other, and you'll apply the policies that are missing. And what I'm going to touch is a software, a library. As a matter of fact, today, with all the tools, simple development tools we have, it would be quite easy to have it graphically without so many difficult things. Yes, and after all that, imagine a network where there's not just one border router, but 500 border routers. How many handle you, Thomas? 70. That's crazy. It's too much. 70 border routers, and all over the world, distributed all around the world. So imagine if every time that you have to do something, this company that has 70 border routers, you have to get manually into each BR to see and remember what you did. It's impossible. So what mechanism enables you to do is to do can manage all the international traffic. You can do it from that little machine that I connected, because the others are backups. You copy the configuration of those. You may have 2, 3, as many as you want. Not 1. 2 is okay. 3 is even better. 4 is better than 3, and 5 might be crazy. It might be too much. Don't overdo it, because if 5 machines fail at the same time, it's not a good thing. So from 2 to 5, from 2 to 4 actually, I would say start with 2 and see if you need a third one. And of course, try to put these 2 in different places of the network. If you can put it in different data centers, yes, and that in large networks that you can, it goes infinite, but then you can anycast them, and you have floating IPs ad infinitum. Yes, and then you can add things, and you can go from white belt to the black belt, going through all the range. And if you lose the communication between the backbone and the border, then you don't have to do anything. And it has another advantage. There are many, but I'm only going to mention the one that Ariel said. Playing with communities, you can also define the state, the international traffic of all the networks from those centralized router management, and you can also define a backup strategy. How does the network respond? How do you modify the international pattern if something happens? And marking it with communities. And when I read those communities and I put one before the other, I'm playing with that. And if one of them falls, if something happens, it's as if the network would configure itself automatically based on the current state. So you can even automate reactions in case of international clashes, etc. You have an endless number, and it doesn't cost much because you need to get a couple of small machines and to install the software that Ariel said, or an FRR, that is free distribution, and you configure it as any border router. And then you have to experiment or to learn a bit how to use internal communities, as Ariel mentioned. So let's go on. Some more general things. Control of prefixes published. Before you go on, let me just say something crazy. Go back to the previous one. If I have a small machine as the one that you're showing there, it's a software router. I mentioned one that is actually a Python library, and it is a Python library. You can do anything that you can do with Python. I could make that Python library in addition to using BGP with the teams, we may be doing some other thing at the same time. I could hook that Python library with some pages that are measuring the quality of the internet, such as Down Detector. I can say, okay, when I find, looking at the down detector, that there's an event somewhere, to react and to change the BGP policy immediately. All that can be done, but in a physical machine it's almost impossible to do it. But if you have it in a software router that is a Python library, of a scripting language library, it has an endless number of possibilities, even to the absurd. If it rains, change the routing, or you can connect it with almost everything, and based on that, the network can get reconfigured. So that is something that today is absolutely possible, and with the assistance, and always being wise, because remember, what you touch of your BGP is seen all over the world. So you need to be wise using AI and the coding assistance. It's not so difficult to do that. Raise your hands if you use monitoring tools for international traffic, such as webmarks or any other thing. Links, and so everybody monitors international links, right? In one way or the other. And do you have some messages or a screen with a nice emoji for the engineers? Webmac is nice, and for others it's just like an absolutely black picture. But engineers like colors rather than pretty charts. So when a link turns red or drops and they say zero traffic, automatically I can trigger an action. For instance, quit publishing or distributing the traffic in a different ways, because the links that I have that connect me with my providers do not tend to have the same capacity. So I can't very happily, gaily send all this traffic through a link that doesn't support the entire traffic. I have to divide the block, and it takes minutes or more, hours. So all along I'm slowing traffic, and with this you can automate it. And if you don't automate it and you do it manually, you can steal it and go down from hours to seconds, while minimizing the possibility of making mistakes because I don't remember what I did where. So experiment with these things. It's absolutely free of charge. Well, it doesn't cost much operationally. It's things you already know how to use, but you use them in a bit more sophisticated manner. Control of published prefixes. Guille, there's even a BGP number. Control of published prefixes, controlling what I publish, filters of publications, good practices, manners. All that in 5 minutes. What do you mean by that? Well, controlling what prefixes are published, what prefixes are received, filtering. Well, the control of published prefixes may also have to do with the number of prefixes that you are published. Yes, well, because the other day we saw an example showing how when we have two autonomous systems, usually we know what we have to publish outside. The filtering of a bunch of things that you need to consider, not publishing things with private prefixes or private autonomous systems or bogans that are things that should not appear in the internet, but publishing only our networks and our customers. That is not too complex when you know what you have in your network. Now, the problem is the other way around. When we are published information, BGP doesn't have those mechanisms to control something that is not appropriate. So, for instance, we need external databases to be able to check that the publications that we are sent by our neighbors are valid, or they are things that that organization may or should or is allowed to publish. So that is why we use two databases, IRR and RPKI. So how do they work? Very similar. RPKI is newer and RIR is older. The idea is that each organization may publish in those databases, in the RIRs or the RPKI, basically the policies for publishing the prefixes. But today, basically, what those two databases do is associating prefixes with autonomous systems of origin. So a system. So each should publish in our RPKR or an RIR the association between the prefixes that they would publish and the autonomous system of origin. So in RPKI, we have to create the ROAS. I'm going to publish certain prefixes through BGP. I have to create the ROAS to say that those prefixes will be published with the autonomous system of my organization. That is of use to others to validate that if somebody publishes in BGP a prefix, makes an announcement in BGP, another organization will be able to validate whether that's right or wrong. So there we have the complement of what we said. It's easy to know what I have to publish, but when somebody publishes me, I don't know. So if I have a BGP session with Nico, Nico starts publishing prefixes. If Nico declared the prefixes in RPKI, I will know whether that is right or wrong. And if some other autonomous system comes and publishes a prefix that Nico declared, that can only be published with his autonomous system, and I receive it with a different autonomous system, that publication I realize that it's not right and I could reject it. And hence we can avoid incidents like hijacking. Well, basically, that is what the slide says. Then there are other things like, well, speak about the limits of prefixes. Well, a comment that has to do with what Guillermo said, the issue of the prefix received is this extra care. That is, you pay attention to those that use null-zero routes, that is, routes by default, that it must be everybody here, and I say almost everybody because if you are a transit provider in a tier 1, you may not have null-zero route, but you may have a default route. So when you generate the route by default, you have to be quite careful to see how you generate that route by default. For instance, some typical cases, it's my peer sends me the prefixes and also the route by defect. The good thing is that if the BGP session falls, I no longer receive the route by default, and that is no longer valid to send traffic. There are other ways. Sometimes the route by default is generated internally in the border routers within the network. You need to be a bit careful additionally. Clear candidate to non-expert. Speaking of communities, yes, and there you have to be careful. And 2, 3, or 4 reviews to ensure that you are filtering the internal use communities, that you are eliminating, filtering the private autonomous systems. If you use private autonomous systems, that you're not publishing private networks, that etc., etc. Especially the combination of route by default and redistribute, that's fatal. Injecting a route by default outbound, usually that should be a practice not on the cover of the book, but the back of the cover book of the book in a. But if there's a problem and that route by default gets propagated to the internet, well, it's almost like doing self DDoS attack. It's like hijacking the routes in all the internet. So you have to be very, very careful showing how you manage the routes by default inside and not to let it out, not propagating the internal. Well, when you do peering, sometimes the BGP sometimes is used a lot in content providers. I'm requested to generate a BGP session that typically it may be multi-hop with some router that manages the provider of the CDN or the cache to inform my prefixes, and then sometimes using DNS or that information, they do magic to decide which is the closest server that will give me traffic. I do a BGP session to inform prefixes. They won't teach me anything. I don't need to learn anything from them. So make sure you put a list that doesn't accept incoming prefixes from the cache servers. Usually that shouldn't happen, but you need to protect yourself. If you not expecting to receive information, filter everything. Usually not appear without routes. Well, by default, never appear without policy. That's what I meant. Of course, today, by default, in the new operation system, and thanks to a new standard, or relatively new standard, the machines don't do anything unless you are applying a policy. You always have to double check. Yes, and this is personal. Don't trust that by default, if there is no policy applied, in spite of the fact that the behavior by default of a modern route, it should be that if you don't have a policy there and first you raise the BGP session and you do things the other way around, instead of creating first the policy and then, well, no. In the past, when that happened, boom, they published everything. Yes, or over-trusting that my neighbor. I don't put the policy because I'm sure that my neighbor will filter right, and I use an automatic machine. My neighbor will be thinking the same as I, and the two of us together, we are going to make the internet a black hole, and we are going to appear on the newspapers and all the newspapers. Yes, you always have to put policies. If you want to publish everything, put a policy saying publish everything, but always have policy for everything. Even if the behavior by default is not publish anything, if you don't have a policy. That's a good practice. And putting alarms, what happens when, well, I wait for my peer to publish, I don't know, 500,000 prefixes, and something comes wrong, and instead of publishing a partial view of the global route of all the routes in the internet, I receive all the route.
400,000 rutas que pueden ser de algún.
So I may get the routes of all the local peering rather big, and I receive 1.5 million routes. Usually there I can do two things. Well, three. Not doing anything, not very advisable. I can set an alarm so that it may send alarm to the syslog, and they say, well, you were expecting 500, and you can put an alarm if it goes over 500,000. But if I get 1.5 million, then the alarm will sound. And I'm saying, well, for this BGP session, I'm receiving 1 million routes. Or you can go a step beyond and say, yes, the number of routes are over a certain value, reduce the BGP session. All those things have both pros and cons. The alarm, the pro is that the router won't make an automated decision. But the con is that it won't filter. If I receive 1.5 million routes, it will accept it. It fills the memory of my router, and bye-bye router. Yes, and the same caution, because in addition to filtering the number of prefixes that I receive, as a matter of fact, there's a study that those of you in the list of LACNOG may have received a tool that was developed at LACNIC, where we analyzed the routing table of IPv6. And in one of the reports they sent, we saw that in the prefixes, in the blocks published in our region, there were some prefixes, I'm looking for it, that had paths of 44 items long. And that's another thing that we should take into account and to have in the filters. I understand that there's no need to repeat 44 times something to be able to balance the traffic in my network.
Entiendo que esa persona estaba muy disgustada porque no.
And I understand that that person was not happy because was unable to have the traffic reaching where it came, and he put a large number just on purpose. But that's another thing that the modern systems can filter. The number of ASNs that come in part attributes, because at the end of the day that occupies memory too. So that should be something to take into account, and some attacks have leveraged on that. Time? Okay. We have 5 minutes left. Anybody? Mariel? Ariel, do you want to explain the black hole? I never know how to translate. Well, it's a remotely triggered black hole. It sounds horrible. Yes, that's a remotely triggered black hole. We have a beautiful podcast that we developed together with LACNOG that speaks very specifically of what this is. But basically, RTVH is a tool that we can use in coordination with our transit providers, so that if any time we receive some attack or an unusual amount of traffic to some direction, or some block of IP directions of the space we publish, we can request through BGP signaling and the use of some communities and small things, we can ask our transit provider to please filter that traffic upstream so that the traffic won't reach our network and consume our links. That is done with a pre-arrangement. Although there's a standard that speaks of a community of BGP for black holes, each provider has developed their favorite number that always ranges around 666, more or less. As a matter of fact, Mr. Thomas Lynch did an exhaustive analysis of all the numbers of the black hole community. That's in his podcast. I recommend it. And it's basically that I'm being attacked. And I can ask my transit provider that all the traffic that I get in an IP address, all the traffic be blocked so it won't consume my links. Basically, it's that. And instead of having to call him on the phone at 3 a.m. and making me pissed, well, to send some BGP commands and nobody will wake up. Well, and the rest are some of the things that we already discussed and some basic things that we mentioned all along. Do not disaggregate more than necessary. You don't need to publish 75 small networks if we can publish just one. Sometimes we have to divide it into 75 so that we can manage transit and balance payload, etc. The issue of using the standardized communities, in particular the no-export community, for a minimum of traffic engineering, so I won't fill the routing, the global routing table full of prefixes that are not necessary. Use the communities agreed with the peers. There you can use these registries of peering DB, where we publish the so-called peering policy, etc. And among other things, you can say, well, we give you all these options of communities that you can use so that your traffic in your known network may behave someone. So putting communities that are applied in the other side of the peer, we can help us manage to a certain extent how my traffic behaves in the network of my transit provider, and some reach even beyond. Thomas may talk about that for a long while later, but there are different things. Geolocalizing traffic. I only want my traffic, my blocks, to be published at certain peers and not other peers. I want my traffic to come here but not to go there. There's a lot of things you can do. And for the first time in history, I'm going to do that. I'm going to finish with style, because for the first time since 2010, in 15 years, we finished this presentation before the time is due. So, any questions or comments? This is the time for comments. Yes, go ahead.
Buenas tardes.
Good afternoon. I'm Antoine of the ISP of Mexico. I have a question about the our peering. We are a small ISP, so sometimes creating the physical interconnections with the ISPs or CDNs may be quite challenging. So as I'm in the process of improving the interconnections we have,
¿Cómo podría funcionar?
I want to understand how those sessions of route peering may work. I understand with multiple BGPs you could establish sessions with the IXPs, but I don't understand exactly how that could be done, or also what would the IXP ask to establish that session.
Yo no sé si entendí correctamente.
I don't know whether you understood. Guillermo, did you understand the question? Yes. Take the mic. Could you repeat it, because we didn't hear the last part?
Enlace remote peering.
You mentioned a remote peering link and how to reach another data center. Yes, the objective would be, in the case I have, how can I establish those remote peering sessions without the need to establish a physical link with the IXP at the beginning? That is, if you want, let me see, if you want to raise a BGP session with a form, if you have an internet transit and you want to raise a BGP session with a remote peering that is more than one hop away, yes, you can do it. That's an essential part of the BGP protocol operations. The only thing, there you have the behavior by default. If you try to raise a BGP session, a standard session by default against a peer that is more than one hop away, it won't work. But because by default, as Thomas said, it's just one hop. You only have to enable, depending on the type of router, the type of command for that. But in Cisco, it was BGP multi-hop and the number of hops. If you don't put anything, it will be 255. I suggest you should put something reasonable, and there automatically they would try to raise a BGP session. The only thing that you will need is to have some way you can reach that that IP address. But if you establish the multi-hub BGP, that it's a the peering you're doing is of a machine that you put somewhere. They are connecting. It would be from my border to an IXP that is in another data center. And my peer 1 doesn't give me the opportunity to physically connecting to this one, so that is why I want to do it with this remote peering. Yes, you can do it like that. There you have several things. You should see there's no tunnel. There are some things. That has the advantage that if a link falls, well, it may if you do it in the border router, maybe not, but if you do it and if a link falls, well, don't forget that BGP always works on TCP, and TCP, if it drops, if it falls, this is going to fall and you're going to have a cut in BGP. It will take 30 seconds to come back, but you are going to have a drop of BGP if it changes the path. And you have to be careful, as Ariel said, because in some rare cases, but it happens, we shouldn't have any loops in the routing, a mess. But if you are careful, then you can do it by limiting BGP. There's a question in the chat? Yes. There's a remote question, Jorge Gonzalez, and it says as follows. Hello. Can you have the case that a hosting web provider may announce a prefix that belongs to a client so that that domain name may be associated to a public IP of the client? The client has the authoritative DNS of that domain using MOAS, for instance. Thank you. I was expecting a question like that. Not. That has to do with DNS and routing. A part that I understand is the provider. I imagine cases such as, well, those that provide services of virtual machines, allowing the client to publish their own autonomous system and IPs. So in that case, yes, Tomás does it. We publish in Bolto, for instance, send Anycast servers that we have virtualized, and we publish with Anycast autonomous system and the Anycast prefixes of LACNIC, for instance. So that is an option. And then what it says of the DNS, I don't know very well what it means. And the rest, it's multiple origin autonomous, the MOAS. Prefixes published by more than one autonomous system. Yes, you can originate the prefixes in any autonomous system, and in that case, you need to be careful, making sure that if you are using RPKI, if you have ROAS declared and you're going to declare the prefixes of autonomous system that is not yours, don't forget generating the ROAS so that you can do it from that or another autonomous system, because if not, all the RPKI world will interpret that that's a hijack and they will filter. I can publish my prefix from anywhere if I'm using RPKI and I have ROAS. I should have ROAS created, so I should go and generate the ROAS authorizing the publication, the origin of that prefix from all the autonomous systems that I anticipate that I'm going to generate the publication. So that would be sort of the care you should have. Yes, you can do it, publishing the autonomous system from several places, or using with Anycast, for instance, for prefixes, as they do in the DNS systems, or generating the words and publishing the prefix from different autonomous systems. Hello, Fernando Tipiani from Peru. This is quite a brief comment for the ISPs that will raise BGP sessions for the first time with their IP transit sessions. It's always recommendable always to check the cache of your router to make sure that you won't overload the routing table, because I've seen overflow it, because that can severely affect your services if you don't check that parameter. That is quite significant. Yes, and consider another thing.
Sobre todo cuando hablamos de dispositivos.
When we speak of devices of the ISP grade, of course, it won't happen in the routers that operate based on software. Remember that there's the issue of plane separation. One has the control plane, the forwarding plane. You can have a data sheet because it's quite common to make mistakes. The control plane of a certain team supports 10 million routes, but the forwarding only 50,000. And the one that you need to program to support the million routes at present, or at least of a table of 4, is forwarding. So you can receive n times the world table in the memory of the team, but then the part that moves the traffic is the one that really needs to have the capacity to have the memory, to have it in their memory. So some data sheets confuse people, and you end up making it possible to have 1 million routes in machines that get overburdened. Yes, it supports the traffic and the number of packets per second. There are some devices that can't handle them, so that you need to take that into account. So, okay, goodbye.